Hello everyone, today we are taking you in a quick journey with the olives from the branch to your fork at home through our project Hazard Analysis and Critical Control Point System Application on Processing Virgin Olive Oil. We have many stations here to stop by, which represent the principle of HACCP plan system. As introducing the HACCP team, full description of the product, flow diagram of the process, hazard analysis, determination of critical control points, adding critical limits, monitoring procedures, and corrective actions. Let's start by the HACCP team members. We have Technical Manager Salwa Tariq, Quality Assurance Manager Suhaila Ashraf, Laboratory Manager Nermeen Fathallah, Hygiene Specialist Salma Sharif, Logistics Specialist Mirna Muhammad, and our external consultant Professor Muhammad El-Zaini. The codex have defined the virgin olive oil as the oils obtained from the fruit of the olive tree Olea Europea L solely by mechanical or other physical means under condition, particularly thermal condition, that do not lead to alteration in the oil, and which have not undergone any treatment other than washing, decantation, centrifugation, and filtration. It also defined the fatty acid content in it. As we see here, we find linolenic, behenic, lignoceric, arachidic, icosanoic, and myristic acid. They are found in specific percentages in the virgin olive oil. Here we have product description, which include 1. Product name, virgin olive oil. 2. Product standard. Oil acidity must not exceed 2%. UV spectrometry less than or equal 0.25. Peroxide value less than or equal 20. Water activity 0.42. Free fatty acid must be less than 3.3%. The density ranges from 0.9150 to 0.9180 at 15.5 degrees Celsius. Viscosity was measured 84 cb at 20 degrees Celsius. 3. Packaging. It's packed in dark container, glass or cupboard, polyethylene terephthalate. It kept away from heat sources between 15 and 18 degrees Celsius. You don't have to refrigerate it, although the refrigeration will not hurt the oil. 4. Where it will be sold. You can find it at the markets, groceries, retail stores. 5. The shelf life. It extends from 18 to 24 months. And number 6. How it is being used. It's used directly. Pour some in a frying pan and start frying with it, or pour it on your salad in salad dressing or in making sauces and margarines. 7. Labeling instructions. If you took any virgin olive oil bottle from the shelf in the market and look at its label, you will find the following written: name of the product, net quantity, company name and logo, nutritional information and ingredient list, nutritional claims and health claims, food additives and coloring agent, contact information like name and the address of the manufacturer, packer, or distributor. You will also find batch number, country of origin, energy content, production and expire date. 8. Special distribution. It's stored away from heat sources and direct sunlight or any light between 15 and 18 degrees Celsius, as we mentioned before. It kept in dry place, handled carefully, don't crowd the bottles. Let's move to a list of product ingredients and incoming materials. The raw ingredients shared in this process are pulp of olive fruit and water. Packaging material: the bottle, dark glass or polyethylene terephthalate. It found in many volumes as 250, 375 or 500 ml. The closure, it's bar top, screw top or wrap tops. Finishing. It could be shrink wrap capsule, raffia, or foil capsule. It is varied according to the factory. Now let's take a look on the flow diagram of the process. First, receiving raw material, which is here ripe olive fruit. Then we check the content of the received material to see if it is as requested or not. If yes, we continue processing. If no, we contact the provider and inform them there is a problem and give them back the whole material. Let's back to if it's yes. We go to cleaning, and cleaning here means removal of the leaves, petiole, and parts of stem may be found there. Next, we move to washing. We wash with water for 5 minutes to remove pesticides, dirt, and foreign materials. Then we go to crushing. Crushing aims to tear flesh cells and facilitate releasing oil. This is done by hammer mills for 50 minutes at 22 plus 1 degrees Celsius. Next is malaxation. They are malaxed for 25 to 45 minutes to allow small oil droplets to combine together. After that, we go to centrifugation. Centrifugation is done to separate oil from pomace, water, and aqueous wastes. Then we have the filtration to filtrate our oil from any foreign matters may be found with it. Then the filtrate go to bottling section at 57 to 70 Fahrenheit. Then it is stored at the conditions we mentioned before. Then the bottles head to the market to be available for the consumers. Here is a plant layout for the production. You can see here the way that the olives take from the tree, then transported, then washed, crushed, pressed, malaxing and centrifugated, then distributed to the markets and to the hands of the consumer. This a better illustration for the previous steps. Here the olives are collected, then stored, washing stage, leaves are removed, then go to the crusher to be crushed, then the malaxer, then to the decanter. The pomace is here out. We can use it in other olive products. We don't get rid of it. Then it go to oil polisher. It separate the water waste from the oil we want. Here we get the clean oil.
First principles hazard analysis may include microbial or chemical or physical agent that cause illness or injury in absence of its control. In our product, the olive oil, the microbial hazards from receiving the olive oil fruit to the processing steps until the extraction of oil can be include the total aerobic count of the collected air sample, which ranged between 1.81 to 1.894 log colony forming unit per plate. Secondly, water. Water, if not clean, may be the main source of the contaminant, equipment, utensils, and the hand of worker. So the main microbial hazard can be concluded as the total aerobic bacterial count, the coliform bacteria, group of yeast and mold, the aerobic spore forming bacteria. A microbial hazard can be controlled by qualified fruit supply, clean, qualified water, proper personal hygiene, handling. And the microbial hazard during the processing steps can be solved by planning and training program for workers. While the physicochemical hazard can be described as the pesticides, the heavy metal enzymatic reaction in the raw olive oil, but during the processing steps include the acidity. The acidity increased as become 1.46% as the olive oil for produced by hydraulic press, which the allowed limit according to the Codex Code B notes the extracted oil using the hydraulic press had a high peroxide value, which result in the oil oxidation and the TPA thioparabutyric acid record a high value. That means that it would be a secondary oxidation, could be controlled at renew frequently with water transportation handling use commonly method for measuring the auto-oxidation states. Second principle, the critical control point, as we determined previously, at which it is the point at which a control measure can be applied to prevent or eliminate, even reduce the food safety hazard. The critical control point not necessarily located where the hazard occur. They may be located at a subsequent steps. بمعنى ان مش لازم كل hazard يقابلني في كل process لازم نجيب له الكريتيكال كنترول بوينت. احيانا في secondly يعني second processing steps هتلاقي لها حل، شبه مثلا الهيت تريتمنت. الخطوه دي خطوه الديدكشن اوف ذا كريتيكال كنترول بوينت. الكريتيكال كنترول بوينت احيانا بنقول عليها الديسيشن تري. We must ask 4 questions for every processing steps. We will discuss the receiving for the olive oil and the same here for other processing steps. Question from طبعا from the receiving of the raw material to cleaning والcrashing والmalaxation until the extraction of oil. First question, does a control measure exist at this step or subsequent step؟ يعني هل الكنترول measure دوت للستيب هل في كنترول ميجر للهازارد اللي موجوده في الستيب دي؟ in the receiving raw material the answer will be no. So should I stop till I found the exist measure or control للهازارد ده؟ Second question, does this step designed to eliminate or reduce a significantly hazard؟ هل الستيب دي تعتبر accepted to control point? In our processing steps we say yes. So these processing steps will consider as a critical control point as it reduce and eliminates the hazard. Second question, could the contamination which is identified the hazard occur in excess acceptable level؟ هل الهازارد عند النقطة دي still acceptance ليه ظهور أو موجود؟ فالأنسر هتبقى no. Question 4, will a subsequently step could eliminate the identified hazard؟ هل في critical control point تانية تقدر تعمل نفس elimination أو الكنترول لنفس الهازارد اللي عندي؟ فالأنسر هتبقى no. We must ask this 4 questions for the other following steps. Third, critical limit. Critical limits, it's a numerical range which ensures that the critical point is done in a correct way, which we illustrated in the table at each processing steps. The critical limit في the last table. Fourth principle, the monitoring procedures. In monitoring procedures sometimes include 2 types, offline and online. What is meant by the monitoring procedures? Monitoring procedure which a process conducting a planned sequence of the measurement to determine if the critical control point is under control or not. الاوفلاين type الاوفلاين ده بيبقى اوتوماتيك، يعني بنشوفه تكنيك، يعني بنشوفه على اوتوماتيك يعني ديجيتال. اما الاوفلاين ده بيبقى بره الماشين، باخد السامبل وبعمل لها ديتكشن وبعمل لها قال لك التستنج بتاعي، بس بيبقى لي طبعا ليه ديس ادفانتج لان ده بيبقى فيه لاس للتايم ولاس كنترول وممكن يحصل دامج للسامبل والسامبل اللي معايا. اكزامبل على البرنسبل 4 هو المونتورنج procedures. المونتورنج procedure of the receiving olive oil method by visual inspection of each item, chemical analysis of the sample, and microbial and physiochemical analysis of the water, and the same with the corresponding steps in the following steps. Principle number 4, which is the correction action. Correction action are predetermined measures that have to implemented when the monitoring indicates that the deviation has occurred. لازم يبقى عندي correction action قبل ما يحصل loss للكنترول ده. Example on the correction action on the receiving of the fruit, we must reject unsuitable item, poor quality fruit, and must poor quality fruit must be processed. يحصل لها معالجة و conduct of the training for operation. Principle number 6, written the HACCP plan, as in the last table, page number 9, which included all the processing steps and all the HACCP principle. Principle number 7, establish verification procedure to ensure the HACCP plan as it complete, valid, and effective, and confirm the plan operating according to the procedures. As the last table include all the verification procedure to each step. Thank you.
Here is our reference if you wanna see and read more about processing of virgin olive oil and HACCP plan. Thank you for watching and thank you for your time. I hope you enjoyed.